Okay. So let's start page 321, number 10. So we're given a diagram that has two triangles embedded in one. Let's see if I can find this thing again. Okay, so you have this gigantic triangle over here. This is a right angle. We have two triangles inside of the second one. Okay, so we have our vertices A, B, C, D, F, and this other triangle has a vertice of E. We want to find out what theta is, and we need to find out what x is, given the fact that this side is 4 centimeters, AC is 8 centimeters, and this is 4.5 centimeters. And we also need to take into account that the angle DCE is equal to pi over 12, okay? So when I say angle DCE, what vertex is that angle on? Let's see if you guys remember. So we're focusing on C, so the middle letter, okay? And what DCE just means is the triangle over here, D, C, and E, okay, with the vertices D, C, and E. So we know that this one already is pi over 12, okay? So to figure out x, we need to figure out what theta is. So if our reference angle is from angle A, what trig ratio are we going to use to solve for theta? So what trig ratio are we going to use to solve for theta? So we're going to use sine, because this is our opposite side, and 8 is our hypotenuse. So we have sine theta is equal to 4 over 8, which is equal to 1 over 2. So what angle gives us a sine ratio of 1 over 2? I'm just going to do the whole question now that I've started, just in case people have the same issue. So what sine ratio gives us 1 over 2 at what angle? What special triangle? Okay, so we get pi over 6 or 30 degrees, okay? So if this is 30 degrees, that means this angle over here has to be 60 degrees or pi over 3, okay? And now what that implies is that angle DCF is equal to pi over 3, okay? But because 4.5 centimeters and x is in triangle CEF, what angle do we need to solve for next? So we know angle DCF is pi over 12. Sorry, I should say pi over 3, not 13. And we know angle DCE is equal to pi over 12. Now we need to figure out what angle ECF is. So how are we going to figure out what angle ECF is given angle DCE and DCF? So we're going to subtract. So angle ECF is equal to pi over 3 minus pi over 12, which is equal to 4 pi over 12 minus pi over 12, which gives us 3 pi over 12, or pi over 4. Okay? So now angle ECF is equal to pi over 4. So now that we know angle C is pi over 4, and we know that one of the sides is 4.5, what can we do to solve for the hypotenuse now? Okay, so we are going to use cosine, which is adjacent over hypotenuse. So we have cos pi over 4 is equal to 4.5 over x. So what does cos pi over 4 give us? What ratio, using our special triangles, what is cos of pi over 4? So we have 1 over root 2 is equal to 4.5 over x. Now all we're going to do is multiply the x over to the other side. So we get x times 1 over root 2 is equal to 4.5. And now what we're going to do is, because we don't want the root at the bottom, so it's going to be root 2 over 2x is equal to 4.5. X is equal to 9 over root 2, which is equal to 9 root 2 over 2 centimeters. So that is how you would solve question number 10 on page 321. Okay, so now we're going to move on to our lesson. So today we're going to be talking about the second part of lesson 2, which is just, we're going to be looking at the unit circle. Okay, the unit circle, there should be a handout about the unit circle in your notes or in your textbook, specifically page 333. So the unit circle is a circle centered at the origin and has a radius of 1. On a unit circle, the value of sine theta is the y coordinate, and cos theta is the x coordinate. Okay? So what that means is, consequently, each point on the circle can be represented by the ordered pair, x, y, where cos theta is your x, and sine theta is your y, where theta is the angle formed between the positive x-axis and the arm of the angle that passes through each point. So we're going to do a bit of review. So we want to convert each of the following standard angles into radians. So how would we write 30 degrees in radians? So pi over 6, so remember we just do 30 times pi over 180, and that gives us pi over 6. So we just did this one with our homework question. What is 45 degrees in radians? So you have pi over 4. 60 is just pi over 3. 90 is pi over 2. 180 is just pi. And 270 is 3 pi over 2. Remember, all you're doing to convert these from degrees to radians is multiplying by pi divided by 180. Okay, so example 2, we want to state an equivalent expression in terms of the related acute angle, which is the angle made between the terminal arm and the x-axis. Okay, so we want to plot sine of 7 pi over 6. So all we're doing, so what is the angle pi over 6? What angle does that give us? 30. So remember from the first lesson, we're going to be splitting each quadrant into 30-degree intervals. So we have 0, 30, 60, 90, 120, 150, 180, 210, 270. Sorry for the awful drawing. And all you're going to do is the numerator is 7. So starting from the origin on the positive x-axis, you are just going to count 7 dots. 1, 2, 3, 4, 5, 6, 7. Okay? So this over here is 7 pi over 6. Okay? Remember our CAST rule. C-A-S-T. Okay? So in what quadrant is sine going to be positive? So sine is positive in quadrant 2, but where does our terminal arm lie on? Which quadrant? So is sine negative in quadrant 3? Yes. Okay. So because it's in quadrant 3, the terminal arm, our sine is negative, and our acute angle is going to be pi over 6. Okay. Because from 0 to 180, That's just 6 pi over 6. And what's left over in quadrant 7 is just pi over 6. So if you use your calculators, you'll come to figure out, if you plug it in, if you type in sine of 7 pi over 6, it'll give you the same thing as if you're to compute negative sine of pi over 6. So the reason why it's pi over 6, so we're still dividing our quadrants into 30-degree intervals, but from 0 all the way to where quadrant 2 is, that is 6 pi over 6, okay, which is just pi. So where our terminal arm lands is in quadrant 3, but it only lands on one of the 30-degree intervals. So this acute angle over here is going to be pi over 6. And because we want an equivalent expression, since sine is positive in quadrant 3, we have to write sine as negative. So negative sine of pi over 6 gives us an equivalent of sine of 7 pi over 6. Okay, the next example is similar. Okay, so we have sine of pi over 3. So to make it easier for ourselves, I don't really want to divide this section into 60-degree intervals, only because we don't land on the positive y and negative y axis. So what can we multiply the numerator and denominator by to give us 30-degree intervals? So how can we get the denominator to be 6? What do we multiply? So we're going to multiply by 2. So this just gives us negative 10 pi over 6. And we can do that because negative 10 pi over 6 simplifies to negative 5 pi over 3. So again, same thing, 30-degree intervals. But because the number in the brackets is negative, are we going clockwise or counterclockwise? So we're going to go clockwise, okay? So we're going to focus on our numerator, which is 10. So we're going 10 sections clockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And this angle over here is our acute angle beta. Okay? So how many sections of 30 degrees are left over? Two sections of 30 degrees are left over. So we can say secant of negative 5 pi over 3 is equal to, we don't know our function yet, of 2 pi over 6. Okay? And what quadrant does our acute angle land on? Which quadrant does it land on? So 1, which means all trig ratios are positive. So secant of negative 5 pi over 3 is the same thing as saying secant of 2 pi over 6, which if we simplify gives us secant of pi over 3. Oh, the 2 just went away because we just simplified the numerator and the denominator. So our next example we have is tan of 3 pi over 4. So obviously we're going to divide each quadrant into 45-degree intervals. And because our angle is positive, we are just going 3 sections to counterclockwise. Okay, so this over here is our acute angle. Okay? So tan of 3 pi over 4. So since we end up in quadrant 2, how many sections of pi over 4 are left over in pi over in the second quadrant? One. Okay? So we're left with a pi over 4. But is tan positive or negative in the second quadrant? It's going to be negative. So our answer is going to be tan of 3 pi over 4 is equal to negative tan of pi over 4. So are you guys starting to, I guess, understand the pattern that's going on here and the concepts? So for example, if it's pi over 4, because pi over 4 is equal to 45 degrees. You're just dividing each quadrant into 45-degree segments. So this is 0 degrees, 45 degrees, 90 degrees, 135 degrees, and 180 degrees. For pi over 6, it is in 30-degree intervals. So 0, 30, 60, 90, 120, 150, 180, and you continue the pattern. There's no, I'm not too sure what you mean. We didn't use exponents. We just multiplied it by the numerator and denominator by 2 to get an angle that we can simply just work with. Oh, the 2 so we know that pi over 3 is 60 degrees. So it's a bit more difficult to draw out 60-degree intervals, mainly because it doesn't hit the positive y and negative y axis. So if we just multiply the numerator and denominator by 2, we can work with an interval that's easier for us to use, and pi over 6 and a denominator of 6 is easier for us to use, because when you divide each quadrant into 30-degree intervals, you end up hitting the positive y and negative y axis and the positive x and negative x axis. Hey, don't worry if you didn't understand it. We're going to keep working more with these questions, okay? So we're going to do the exact same thing for example 3. So we want to determine the exact value of each trig ratio using our unit circle, okay? So the first one is sine of 330 degrees. So this would be 330 degrees, okay? So how much is left over for us to complete a 360-degree circle? 30, okay? So you have 30 degrees over here. So using the cast system, is sine positive or negative in quadrant 4? So sine is going to be negative. So we need to determine the value of negative sine of 30 degrees. So using our special triangle, what do we get when we take sine of 30 degrees? So remember, 30 degrees is the same thing as saying pi over 6. So it's going to be 1 over 2. So we get negative 1 times 1 over 2, which gives us negative 1 over 2. So that means negative sine of 30 degrees is going to be negative 1 over 2, okay? If you were to do sine of 330 degrees on your calculator, you would get 1 over 2 as well. Okay, so now we're going to move on to the next one. So we have cosine of negative 3 pi over 4. Okay, so we're going to divvy it up into 45-degree intervals. And because it's negative, we're going to be going clockwise. So we get 1, 2, 3. So this is negative 3 pi over 4. And now the question is, how many pieces of 1 over 4 is left over? So we have 1. So we have a pi over 4 left over, okay? Is cosine positive or negative in that quadrant? So it's going to be negative. So this is just equal to negative cosine of pi over 4. And using our special triangles, what is cosine of pi over 4? Root 2 over 2. So we get negative times root 2 over 2, which gives us negative root 2 over 2. And for C, we have cosecant of pi over 3, which is just over here. So remember, cosecant is just the same thing as saying 1 over sine. Okay, so what do we get when our special triangle is pi over 3? What is sine of pi over 3? Use your special triangle notes. What's sine of pi over 3? So sine pi over 3 is going to be root 3 over 2, which is equal to 1 over root 3 over 2, which when we simplify it gives us 2 root 3 over 3. So the reason we didn't have to make cosecant negative is because the angle lies in quadrant 1, which means all ratios are positive. So all you're doing in this lesson is just drawing out the terminal arm and seeing in what quadrant it lands, okay? And if it lands in a quadrant where the trig function is negative, then you're gonna make your trig function negative. Okay, so what we're doing next is tan of 3 pi. So from 0 to 180, that's 1 pi. From 180 to 360 is 2 pi. And from 0 to 180 again is 3 pi. So we have the points here of -1 and 0 based off our unit circle. So what we need to do is figure out what sine of 3 pi is and cosine of 3 pi, okay? Because remember, the point xy is cos theta and sine theta. Sorry, it's the other way around, sine theta and cos theta. So if we do sine of 3 pi, what does that give us? So sine of 3 pi is 0, and cosine of 3 pi is -1, okay? So when we want to calculate tan of 3 pi, remember tan of 3 pi in a ratio is just y over x. We know our y value is 0 because cosine gives us 0. And we know our x is -1 because cosine gives us -1, which means tan of 3 pi is equal to 0. Okay, so just for your guys' reference, this is what the unit circle looks like, okay? So as you can see, with a radius of 1, we have the major points at 1 and 0, 0 and 1, negative 1 and 0, and 0 and negative 1. Okay? So remember we said our cosine is our x and our sine is our y. So at each point, so we have 30 degrees as our first point. So we're going to determine cosine of 30 and then sine of 30. So cos of 30 is root 3 over 2, and sine of 30 is 1 over 2. Okay? And you're going to do the same thing with 45 degrees and 60 degrees. Okay? And all you're doing for everything else in the other quadrants is you're just turning one or both of the numbers negative. Okay? So for example, sine of 120 is in quadrant 2, and we know in quadrant 2 the x value is negative. Okay? So 120 goes hand in hand with pi over 3, which is 60 degrees. So we would look at 60 degrees. It's 1 over 2 and root 3 over 2. So that means 120 degrees in quadrant 2 is just going to be negative 1 over 2 and root 3 over 2. Okay? And you're just doing the same thing with all of the other angles. So I'll explain this more tomorrow, the unit circle, so that you guys have a better understanding of it. I know it can be confusing. I know I found it confusing when I was taught this, but now I'm able to understand it a bit better. So the next one we have is cotangent of 5 pi over 6. So we're going to divide it into 30-degree intervals. One, two, three, four, 5. So this is 5 pi over 6, which means we're left with pi over 6. Okay? So now we need to ask ourselves, how do we figure out what cotangent of 5 pi over 6 is? Okay? So remember the cast rule. So what function in that second quadrant is positive? So what trig function in the second quadrant is positive? So sine and which one is negative? Cos, okay? So remember, our sine is our y value and our cosine is our x value, okay? And based off our trig ratios, we know tan is equal to y over x. So what does that mean about cotangent? What does cotangent equal? X over y. So what does sine of pi over 6 give us? So it's going to give us 1 over 2. And what is cosine of pi over 6 going to give us? But remember, because it's in the second quadrant, it's going to be negative. So negative root 3 over 2, which means cotangent is equal to x divided by y, which is equal to negative root 3 over 2 divided by 1 over 2. the 2's cancel out, so we're left with cotangent of 5 pi over 6 is equal to negative root 3. So just comment in the chat if you're understanding or not understanding. And don't lie. Yep, that's what we're basically doing, Joseph. Okay, I need more answers, everyone. So how I got negative root 3 was because of negative cos pi over 6. That gives us negative root 3 over 2. And sine of pi over 6 gives us 1 over root 2. And because tan is equal to y over x, that means cotangent is equal to x over y. So all we're doing is taking negative root 3 over 2 and dividing it by 1 over root 2. The 2's cancel out because if you were just to divide them normally, the 1 over 2 would just flip. So the 2's would cancel out anyways, and you're just left with negative root 3. So I got 50-50 on the understanding and 50% on the not understanding. So I'm probably going to have to go over this again, which I don't mind because I don't want you guys feeling lost. Yeah, this trig unit, we're gonna have to do a lot of examples together. And the fact that I can't see you guys in person more than once is gonna suck with trig. But we're gonna have to pull through it somehow, some way. So the last example we have, or second last, is we have f, which is secant of negative 3 pi over 2. So we're going to divide, basically pi over 2 is just 90 degrees. So every 90 degrees, we're going to split up our points. And because it's a negative, we are going to go clockwise. So 1, 2, 3. This gives us 0 and negative 1. So remember, secant is just equal to 1 divided by cosine. So secant is equal to 1 divided by cosine of negative 3 pi over 2. And because cosine is our x value at the point 0 and negative 1 is going to be 0, which means secant of negative 3 pi over 2 is going to be what? So what's any number divided by 0? That's not 0. It's going to be undefined. And last but not least, this is probably the easy example out of all of them. So we want to evaluate sine of pi over 3 times cos of pi over 6 plus sine of pi over 6 and cos of pi over 3. So we're going to be using our special triangles. So what is sine of pi over 3? What does that give us? So root 3 over 2. What is cosine of pi over 6? Root 3 over 2 as well. What is sine of pi over 6? One over 2. And what is cos of pi over 3? It's going to be the same thing. So we're just going to multiply. So root 3 times root 3 just gives us 3. 2 times 2 gives us 4 plus 1 over 4. And when we simplify that, what do we get? One. Okay, so I know this is probably a very hard lesson. So tomorrow, if you have questions about the homework, come during the time before class, and I'll explain this even further. Try to do the homework, okay? Remember, tomorrow you have a quiz on Unit 4, which is the rational inequalities. So that's just a multiple choice quiz. So try your best to do the homework as best as possible for this lesson. But if you don't understand it, I will completely understand. It's not an easy thing.